It's asked to find the current through AB, AC and BC of the network. We need to apply the two laws related to circuit, the KIRCHHOFF's laws. First rule say the total current entering a junction equal to the total current leaving the junction. Second rule, the total potential difference over a closed loop will be zero. When you apply the loop rule and junction rule, you need to have currents marked in the diagram first. In this question, the arrow mark is already given. So if you take current through CAS I, at A, this current can split into two. Current through AB can be I1. From I1 go through AB, so remaining I minus I1 comes through AB. Now this cell, they've given a current from E to B. We take that as I2. At B, I1 and I2 will join. The current coming down through BC will be I1 plus I2. And from that current at C, I will go left. The remaining current will be I1 plus I2 minus I. The current through CD will be I1 plus I2 enter C. From that I will go to CA. The remaining will come to CD. At CD, I1 plus I2 minus I join with I minus I1. So minus I1 get cancelled with I2 back. When you apply the loop rule, you take the potential across resistor as positive, negative as per the current direction. There are different conventions. One convention, you mark the current flow entering resistor as plus, leaving as minus. So current enter resistor through positive potential, it leads to negative, leaves from the negative potential. Current flows from higher to lower potential across the resistor. Since current direction is given, entering point is plus, the current leaving is minus. So here the current enter through left side, leaves through right side, enter through and leave through left side. Here the current enter from A to the resistor, so plus, leaves from the right and minus to B. So for CD, current is coming from top plus, leaves from the lower and minus. From B to C, the top end is plus because current is entering, the lower end is minus. For a cell, already the longer terminal is plus, the shorter one is minus. Now, if you apply the loop A, B, C, A, B, C, A to B, there is a potential 4I1. Since the current is leaving from the terminal, the potential will be minus 4I1. The sign of the potential is the terminal sign from where the current is leaving. That's minus. Minus 4I1. From B to C, minus 2I1 plus I2. You open the bracket, minus 2I1, minus 2I2. Now from C to A, there's a 1 ohm resistor with current I. It's leaving from the negative terminal, so minus I. Hence a cell, the current is leaving from the positive terminal to the left, so plus 10. Total potential difference is 0. We'll repeat once more. When you apply a loop rule, mark the terminal of the resistor where current is entering is plus, leaving as minus for all resistors. When you apply the loop rule, the sign of the potential difference is always the sign through which you leave the loop by taking this ABC path. Whatever path you select, if you exit a resistor or cell, that exiting terminal is the sign of the potential difference. Whether it's a cell or resistor. This is one sign convention. There may be different sign conventions applied. We reduce this minus 4i1 minus 2i1. So minus 6i1. Then minus 2i2 minus I plus 10 equal to 0. We take all the negative term to the right side to become 10 equal to 6i1 plus 2i2 plus I. Number 1. Same way apply for the loop ADCA. Starting from A to D, 4 times I minus I1, but it's leaving from the negative terminal when you go from A to D. So it will be minus 4. When you open the bracket, minus 4i, minus of minus 4i1, so plus 4i1. Now D to C, you're going from negative to positive terminal. So the potential is positive since you're leaving from the positive terminal. It will be 2 times, open the bracket, 2 times I1 plus 2 times I2 minus 2 times I. From C to A, you go back. This 1 ohm resistor, you're leaving from the negative terminal. So the potential is negative I. Then from the cell, you're leaving from the positive terminal. So plus 10. So total 4i, 2i, and so you take everything to the right side. So 10 is equal to 4i here, 2i, I total 7i, negative 7i, 4i1, 2i1, 6i1. You put the right side as minus 6i1 plus 2i2 will be as minus 2i2. Question number 2. There are 3 unknowns in the equation. Anyway, you need 3 equations to solve. So third equation you can take from the right loop. So that will be D, E, B, C, D, C, D, E. So D to C, you're leaving the resistor from the negative terminal. So minus 2 times I1 plus I2. So minus 2I1 minus 2I2. From CD, you're leaving from the negative terminal going around the path. So it will be minus. When you open the bracket, minus 2 I1 minus 2 I2 minus minus plus 2I. Then from the cell, you are leaving from the positive terminal. So plus 5 back to 0. So 2i1 minus 4i1. Then I2 minus 4i2 plus 2i plus 5 equals 0. Or you can take 4i1, 4i2 other side. So it will become 5 equal to 4i1 plus 4i2 minus 4. number 3. Now it's mathematical terms how to solve I1, I2. If you see equation number 1 and 2, by luck here, the 6I1, so minus 6I1, so 2I2, so minus 2I2. That means if you add equation 1 and equation 2, 6I1, 2I2 terms get cancelled. So equation 1 plus equation 2 gives you 10 and 10 add up to 20. The right side 6I1, 6I1 get cancelled. 2I2, 2I2 plus minus get cancelled. I plus 7I will be 8I. So that solves I for you. 10 by 20 by 8, 10 by 4, 5 by 2. So I is equal to 5 by 20. You can use I in the third equation. It's current A. So A in equation 3 will give you 5 equal to 4I1 plus 4I2 minus 2I. 2 into 5 by 2, 5. So this 5 will go to left side, 10. So divide by 4, simplifying 10 by 4 equal to I1 plus I2. So 10 by 4 is 5 by 2. So that's equation number 4. So now you have one more equation. You need one more equation to solve I1 and I2. That you can apply A in equation 1 or 2. This A in 3. Now substituting A in equation 1. So minus 10 is equal to, not minus, 10 is equal to 6I1 plus 2I2 plus I is 5 by 2. If 5 by 2 go to left side, 10 minus 5 by 2. 20 minus 5, 15 by 2. So 15 by 2 equal to 6I1 plus 2I2. If you reduce dividing by 2, 15 by 4 equal to 3I1 plus I2. Now we have two equations to I1 and I2. The equation is I1 plus I2 equal to 10 by 4. So if you subtract these two equations, 15 minus 10, 5. 5 by 4 is equal to 4I1. Subtracting. So 2I. So that means I1 equal to 5 by 800. 5 1 is 5 by 8. You can substitute in I1 plus I2 10 by 4 to get I2. So I2 is equal to 10 by 4 minus I2. So 10 by 4 minus I1 is 5 by 8. So 20 by 8 minus 5 by 8. 15 by 8. 5. Now current through AB same as I1. I1 you got already 15, 5 by 8. Current through AC is just I. I we got as 5 by 2. Now current through BC is I1 plus I2. I1 plus I2 we already got as directly 10 by 4 amperes here. Now, if you want to find current through AD and CB, current through AD is like I minus I1. Current through CD is I1 plus I2 minus I. So I minus I1 through AD. If needed, not asked in the question. I minus I1. I is 5 by 2 minus I1 is 5 by 8. So 15 for 8 for 20. 20 minus 5, 15. So 15 by 8. Now current through CD is I1 plus I2 minus I. So I1 5 by 8, I2 15 by 8 minus I 5 by 20 by 8 minus 5 by 2. 20 by 8 you divide 10 by 4, 5 by 2. 5 by 2 minus 5 by 2. So now current flows through CD.